Hello mathematicians, let's have a look at the last of our rules for a little while, and that is the quotient rule. So clearly this one's about when the function is written in the form of a quotient. So that is that y is one function of x divided by another function of x. And again, this rule, while it looks complicated, and I suppose it is, that rule is on your reference sheet. And you can set it up formally. So for example, for this question here, we could say we'll let that be u and that be v, and we'll find du dx because we know we'll need it at some point, so that will be 1, and dv dx because we'll need it at some point, so that will also be 1, and then substitute into this formula. So dy dx equals v, which was x plus 1, times du dx, which is 1, minus u, which is x, times dv dx, which is also 1 in this case, all over v squared, which is x plus 1, all squared. We tidy that up. So the top line is then x plus 1 minus x, which just comes down to 1 over x plus 1 squared. Now, as you'd expect, I've got a lazy way of doing this that I'd prefer you to do, because in practical terms this will often just be one step in the process. So let's have a look at that. So this is how I'd like you to do it. I'd like you to read this to yourself, and the way to read it is that the dy dx equals, take the bottom of your quotient, put it down the bottom and square it, then put it up the top, multiply it by the differential of the top, minus, put down the top, multiply it by the differential of the bottom. So if I looked at this one, for example, and applied that rule, it's just slightly less writing. I don't do all of this setup, but I've clearly got to do it in my head. So I look at this and it's got a top and a bottom. It's a quotient. So take the bottom, put it down and square it, then put it up the top, multiply it by the differential of the top, which is 1, minus, put down the top, and multiply it by the differential of the bottom, which is the negative 3, and then tidy things up. So I've got 1 minus 3x, and then these two multiplied together will be plus 3x. So again, it doesn't always work out to be 1, this is just a coincidence. So it becomes 1 over 1 minus 3x all squared. Okay, so I might just do a couple of the ones down below, so they're a little bit more complex. So I'll do the d and h. So for d, I've got that y dashed, or dy dx, or even f dashed of x if they've written it like that, is, I see a quotient. Put the bottom of the quotient down, square it, put it up the top, multiply by the differential of the top, minus, put down the top, multiplied by the differential of the bottom. I've got x minus 1 minus x minus 1, so it comes to that. This one over here, quotient, put down the bottom and square it, put it up the top, times the differential of the top, which will be negative 4, minus, put down the top, times the differential of the bottom, which will be plus 4. Simplify the top, so that will be negative 20 minus 16x minus 20 plus 16x. The 16, and that's all over. And this is, I nearly did what is the most easy thing to do, which is to lose the bottom. So that will then come to minus 40 over 5 plus 4x all squared. Now there could be questions which ask you to do things like find where the tangent is horizontal, find the equation of the tangent and so on. And all that we've done is we've looked at a way of finding that first differential. And once we've found that, we apply that knowledge to any questions that we've come across before. I just do number 4 here because I think it's interesting, because we've got options. So with this thing here, I can think of it as a quotient. So part B says do it as a quotient. So if I think of it as a quotient, then y dash would be, put it on the bottom, square it, put it up the top, multiply by the differential of the top, and the differential of 1 is 0, minus put down the top, multiply it by the differential of the bottom, which is 3. So that gives me negative 3 on 3x minus 2 all squared. However, if it's really a simple one like this, sometimes it may be better off to think of that as y equals 3x minus 2 to the minus 1. Even if that's a number there, like 4, I could make it 4 times 3x minus 2 to the minus 1. And then I can use my function of a function rule, my chain rule. So I'm going to get, if my pen works, I'm going to get y dashed equals, so multiply the minus 1 down, minus 3x minus 2 to the minus 2, times the differential of the brackets, which is 3. And if I write that back in original form, I've got negative 3 up the top and 3x minus 2 squared. Up to you. Okay, so go now at 7g.